Hey guys, so today I'm actually going to make some drive rolls or spider hubs, or I don't really know what to call them. I got 2 pieces of 316L stainless steel. I'm going to face both sides, and then after I face it and put a slight chamfer on both edges, I'm going to go over to the mill. I'm actually going to make these both the same thickness too. And then I'll go over to the mill and I will use a 5 flute carbide end mill to plunge. It's a 1/2 inch diameter to plunge down about 500 thousandths, like across. So here, 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 and here. And I'll show a picture of what this will become for the food place that I do work for. All right, so let's get the machine. So now that I got the first side done, I'm gonna leave it over here. I'm gonna do this one. So then when I go to do my work, I can indicate everything off the back of the chuck, and I know that both pieces will indicate pretty closely to the same dimension with the readout, and it'll just make things a little bit quicker and easier. I don't know if you guys saw before, I didn't explain it, but I used a 246 block against the tool post to get the puck right here pretty close instead of trying to use two parallels off the back of the chuck. I know that I set this quick change tool post off of the chuck with a 246 block, so there's no reason you can't use a 246 block off the tool post to do the same kind of work as far as getting this to line up. So let me show you. Yeah, most people say, oh, never leave your tool. I'm the only one that works here. So if I mess something up or if I hurt myself, well, guess what? It'll teach me not to do it the next time. You can still see I need to go a little bit more so that side gets cleaned up. Another 10,000ths of an inch. And that's 625 RPM. A little goldish color. Take the heat out on the chip itself. Don't leave the heat in the part. Meaning that if you try and take too light of a cut, depending on your surface feed, you're actually going to get the part warm, and you're not going to. You can actually change the dimensions of the part a lot. So. Now that we have that machine surface, we want to make sure it's true off that face of the chuck. So I just make sure it's clean. And then you take this nice fancy magnetic, make sure it's clean. I think this is actually called the chuck spider. Now we can put that piece just in like that. So now I have to drill. I'm going to use a center drill, which is this. Basically, it's a very short drill bit, and because of the larger body diameter, it's also very rigid, and it also has a built-in countersink, which is the right taper for a live center, which could support material at the end of a workpiece. So you would drill this, and then you would hold it like that. But since this is a short workpiece, we need to put a hole in it. We're just going to use this to start our hole, and then go to 5/16 because we're going to actually drill and tap this for 3/8 16. This center drill is way too big. I'm going to use this one, which is more appropriate for this size hole. Here's that 3/8 16 tap, which I'm going to be using some tap paste for it. I just do that just to start and have this tap be aligned. So then I loosen up the chuck. Oh. I'm like leaning over the tripod, so it's not really the easiest place to tap a hole leaning over all this, but I'm doing it for you guys. This lathe also has a brake, a safety brake at the bottom. It's like a big foot bar, and I'm standing on that right now so the truck doesn't turn. This is the only thing I can do. That's just like the backlash of the actual shoe itself of the brake. I'm gonna chuck this up and hopefully it'll do a nice deburring job. Slow it down a little bit. Doesn't seem like the straightest countersink, but it's all right. You guys can see that it looks pretty good. Now just got to do the second one. So the reason I did that, actually, let me just show you why I bumped it. The quill actually has numerical graduations on it, so I set it to 1 inch, and then I bumped the bit up until the bit is actually just about to touch the workpiece, so I know that when I go in the 5/8 that I want to drill, I know that it's pretty much roughly from the front of that hole, and I'm not going to drill through the other side for this blind hole application. So this is a 5/16 drill bit, but I guess it's really just to make Curtis happy, because I don't know if you guys can see that, but it does say 7.94 millimeter. Now that we got that done, we'll put the chuck back in, and I usually only give it a good hand tightening, and that's all I want. I'd rather it spin than grab and get pulled all the way in. So the spiral flute is really nice, especially for the blind hole, because instead of actually pushing the chips forward, and then, or forward meaning towards the chuck, it'll fill the hole up with that swarf and it'll break the tap instantly if you're not careful with it, whereas this will actually draw the swarf or the chips away from the workpiece. So it's nice because then you can theoretically go down to that hole. Now I'll step on that brake. Notice how it doesn't spin anymore, and you can see how, look, the chips, they come out the front, and that's nice because it's not going to load up on the inside of this hole. We're about like halfway down with the hole with the tap. Looks really good. I'm just going to do a double check on that just to make sure it is at the bottom of that hole. I don't have to put any more tap paste on it just because if it is going to turn, it's only going to be a quarter or half of a turn really. And there is enough residual, yeah, right there. It just feels like it just wants to flex instead of turn. So you always want to be careful and get that good feeling for a tap, because look, it's so much easier to back out a tap that's not broken in half than to break the tap in half and have to deal with all that. So trusty dusty spiral tap. So let's see what we got here on this one. We should also, basically it should look identical to the other part I showed you first, where you can see the hole is threaded. There we go. That's it. Hey guys, so what we just got done was turning down these spider hubs, I'm gonna call them. Did the 3/8/16 drilled and tapped blind hole. So now I'm gonna put these have to actually get cross drilled. So I'm gonna use a 1/2 inch, I thought it was a 5 flute, but it's not. It's just a 4 flute end mill. It's solid carbide. And I'm going to put that 1/2 inch diameter hole in 4 spots, and it's going to go in also 1/2 of an inch from contact here. So now it's locked in place, and I have to get a center dimension on here. What I also want to do is I'm going to bring this vice stop up and contact this, so we have 3 points of contact with the vice unlocked, so I know it's going to be in a good spot. By a good spot, I guess I mean it'll have nice repeatability, so every time you rotate it for the next hole, the accuracy of the job will still work out. This little edge stop right here is from Edge. That's the name of the company. That's who also makes this tray and a couple other neat little gadgets I use for machining. So now that we have our 3 points of contact, there's 2 dimensions that we have to find for the digital readout. And really I can zero this because it's irrelevant. They're gonna change as we start to locate this part. Make sure that we're still in the camera with the DRO. All right, so now what I want to do is I want to get rid of this chuck. I could put an edge finder or the end mill into this chuck, but don't know, I feel like collets are a little bit better for position and for work holding when possible. So this is a 3/8 shank. This is an edge finder. I'm going to show you how this works. I'm going to switch it into this collet. Some of these collets stick in the drill bar a little bit, but so this is a collet. This is a drill chuck with a 1/2 inch straight shank on it. So I'm going to put this back, grab my 3/8. So this is my 3/8 collet, and you can see that the edge finder fits snugly in that. So that's just it's a butterfly impact gun that's from eBay, and actually works pretty nice for tool changing. Here, let me see that up there. Okay, so now the edge stop is in. So an edge stop we're going to use to indicate the center of front to back, but we also want to find the center from left to right. All right, so you can see that the tip right here is going to want to touch, and let me try and zoom in so you can see this a little bit better. Now that you can see that, I want to start up the mill. And I'm in low gear, so I'm just going to crank it up until I get into my 500 RPM. All right, so now you see the edge finder. So you can see how it can move off of center. So now that it's not centered, it'll be easier to show you. I'm going to bring the table over until this actually starts to hit, and then once it engages enough contact, it'll actually roll itself on the material, and that's when I know that this tool is centered. Well, this diameter is 200 thousandths, so once it touches, if I move the table 100 thousandths of an inch towards this, I know the edge finder is now centered over this area. So basically what we'll have to do is we'll have to make sure that this edge finder trips at this location on this side, and then we'll have to find the other side and use the digital readout to do half a dimension, and it will actually center this. So I hope that made sense. I'll just do it and hopefully you guys will get it. So it's starting to vibrate less because it's coming in close. See how it's shot over? So now I'm going to clear my Z on the digital readout, and I'm actually going to do it again to make sure it's in the right spot. Yeah, so it's only reading 1/10 off on the digital readout, so I'm going to 0 that. And then, without moving it, I'm going to come off the workpiece. Do the same thing to this side. So right there, I'm going to zoom out to show you guys. So now with this tripped over, Look, on X half. So now that right there so now we're over center. Now we can lift our quill up so we can try and find the front and the back. So now Y, half. And now we're centered over the workpiece. See? So now take our half-inch collet back, put our 3/8 back, put the half-inch collet up in here. Put the clean edge finder back in its little sleeve. So now what we want to do, put our end mill in, and really an end mill you only want to put it into the collet almost as far to where this radius right here is going to touch, because the more choked up you are on it and the less stick out that there is, there's less room for deflection, so it's a much sturdier or rigid setup. But some jobs you need to, cheat a little bit and get the length you need sometimes. So that's approximately where I'm going to start. So I'm going to reset up my handle so it's in a good position. Right there. Hey guys, so I set up my Noga. This thing works awesome. Zeroed out at 500 RPM. Well, I just ran it the wrong way, so probably just hurt the end mill. That was kind of stupid. So what I'm doing is just gauging that witness line of light and just making sure it's pretty parallel. But you can see how there's actually a little bit of play. So I'm making sure that the tip is just a little low on the line gap underneath between the daylight of the end mill and the 1, 2, 3 block. And basically now, for the kind of application that it is, this is serving, it's fine. There's actually just 1/2 inch stainless 316L round bar that's going into here, and it's spanning about like 20 inches per length. So even if it is off a little bit, it's not a big deal because the pieces that we're working with, each one was like handmade in China and the tolerances were pretty poor. So even if this is off a little bit, it'll still be more accurate than what we're working with. It's kind of a nature of modifying things in the industry. So now that that's locked up, I'm going to turn I'm actually going to set this up to be on the 246 block, because then I can actually have it point down a little bit to get into that hole better. And I'll turn the mill on the correct direction this time, which definitely works. I usually have this thing in low gear all the time. That's why I had it at 500, but it wasn't. It was actually at 4,200 RPM, and I ran it in reverse. I do a lot of what I would say larger diameter, like annular cutters and stuff on here. So typically, and I also use it a lot for drilling holes, so I usually only have it from 60 to 500. I was doing aluminum last time and I never switched it back, so it's always good to be mindful of what your equipment was set up for in a previous job. So now that I have that running, I'm going to step over here just so you can see, or so I can hang on this a little bit better. What I want to do is just, when it starts to touch, I just want to make sure I'm close to 0. So you'll see that as I'm starting to drill, because I'm drilling with an end mill, it's not designed to be drilled like an actual drill bit. So it is going to get warmer much quicker. It's got very hard corners on, very sharp corners on it, and it's a very, you can see it's a flat bottom cut. So with the mist going, I'll still lift up, let it. First, it's letting the end mill cool down, but you're also helping get coolant into the hole, and then drill again. It's called pecking when you're drilling like this to break chips. I don't know if it's called a coolant peck or something else. I don't know. But I'm at 0.36 almost. So another 140 thousandths to go. $420,000, a good number. 450. Sometimes when I'm close to the end, I don't want to lift up because I'm impatient, and I'm like, oh, I'm there, I can finish it. And with 300 series stainless steels, you can see that there's some yellow or straw or gold in the chip color. That's okay. But this material, if you dwell, like if you just sit there and let something rub, like the tool rubs on the work, but it's not removing chips, 300 series stainless, it will do something called, and I over drilled it by 8 thousandths, but that's okay. It'll do something called work hardening, and basically it'll turn the stainless into like almost carbide. It's called like carbide precipitation, when basically you overheat it and it gets so hard that you'll damage every tool you have besides like a die grinder for the most part, or an abrasive grinding wheel or stone to try and break through it. So when you're using or working with 300 series stainless steels like this, you really want to make sure that when the tool is
touching the work, that it's removing a chip. If it's touching the work and not removing a chip, it's a bad recipe, or it's a good recipe for disaster. Fortunately, I like to try to be a little aggressive in my ways, so as long as I'm not spinning the part too fast, like stainless, you need to be running so much slower. Like if you do a lot of work with steel or aluminum, but don't do stainless stuff too often, bring your speeds way down. You'll never have enough lubrication. You can never have too rigid of a setup or have too sharp of a tool when it comes to stainless as well. If you have like a dull drill bit and you're trying to drill through aluminum or steel, you can force it through, you can get a hole. If you have that kind of drill bit and you're trying to work with a 300 series stainless, because it's not sharp, you're putting so much extra friction onto that, it's a great way to like friction weld your drill bit or snap your drill bit because of friction welding to the workpiece itself. Just try to help you guys out a little bit with a little bit of information as I go. And I know that some videos I post are literally just what I had on my phone, and there's no commentary or anything. Not that I know if you guys like the commentary or not, let me know in the comments. Please feel free to like and subscribe and put on the little bell for notification, like a little bell. And I appreciate you guys. So what we'll do is we'll come walk over with our 2, 4, 6 and our 1, 2, 3 block. Carbide touching carbide always chips carbide, so it looks okay. Even though I said it's not critical, I still worry too much about things, because why not? Correct rotation again. We're off to a good start now. We're starting to remember how to do our job. So you hear that little bit of a chatter, like a bounce in the beginning. That's because that flat end mill is only trying to touch a little bit of that outside radius, and it wants to hop around. So until you get full contact of the end mill, or the full diameter of the end mill that you're using to cut, it's going to want to do that. So you don't want to put as much downward pressure, because you can actually cause that end mill to try to walk around a little bit or deflect on you. So just lighter pressure until you're engaged, and then go as hard as you're willing to sacrifice a part, really. We're at 300 thousandths. I grab a little lever up here. I don't know if you guys can see it when I'm zoomed out, but it's basically just a brake. So when I turn it off, I pull the brake, so I don't have to wait for it to slow down. So it's just faster. I can get my paws in there without risking losing some nubs. I wasn't always against my stop. That would have drilled a very off-center, terrible hole. I always do stuff like that when I'm not paying attention, because you overlook stuff like that when you're not paying attention. So, pay attention. It's a lot easier to do a job correctly the first time and all that fun stuff. So about 15 thousandths. And I don't know if you guys can see it, but it chewed through the two high spots, and it gave itself at least enough of a vertical like land or an edge that it helps keep the end mill stable and centered. This end mill used to cut very nice before trying to cut in reverse with it. 420. Such an easy number to point out. Looks nice on the display, probably. 497 and like 5 tabs. Hey guys, so this pretty much wraps up the machining of these two spider hubs. I'm gonna make this a video for now, just so it doesn't get really long, because I have a hard time trying to find the end of a video. I always want to make like a 3-day video. And so that one. I appreciate you guys sticking around and watching. Please leave comments on what you think I can improve on, or what kind of video you think that you would like to see next. And I'll be right back. So these are gonna end up getting welded. And just like that. So, lollipop, lollipop. I'm just kidding. Thanks, guys.